Hello, my name is Caitlin Rodriguez Rivera, and this is my Physics 2212 Lab 2 Lines of Charge. The purpose of this experiment was to determine the excess charge that could be found on one of the pieces of tape used in this experimentation process. The results include that the charge on each piece of tape was determined to be 2.05 times 10 to the negative 8 coulomb, and each piece was determined to have a coefficient of 1.3 times 10 to the 11th electrons. Some fundamentals include Newton's second law that states that an object's acceleration is proportional to its net force along with gravitational force near Earth's surface. Another fundamental is the E field for a rod with uniformly distributed charge, where our observation point is perpendicular to and on the center line of the charged tape used. A final fundamental is Coulomb's law, which is an electrostatic force between two stationary points, which is equivalent to the product of charge and a known electric field called electric force. Some key assumptions used were that the charge were evenly distributed along the length of the tape and that any air resistance was ignored. In this experiment, the system was the two pieces of tape used, and the surroundings included all other materials present in the work, along with some initial conditions. Here is the experimental procedure used, which is the same one from Lab 1, in which tape B was attached to one of the pieces already stuck to the work surface and rubbed to generate a charge, before being removed from its position and held against several objects to determine its charge. It was then placed against tape A, which was also charged in a similar manner and held against it until a portion of the tape floated. The distance between the two pieces was measured to calculate its charge. Some observed interactions from the experimentation process for Lab 1 include that the U-tape was repelled by another U-tape, the U-tape was attracted to the charged plastic pen, that therefore showed that the U-tape was positively charged. It also repelled when interacting with the suspended U-tape, that gave a separation distance of 0.02 meter. Here are some experimental calculations gathered, including the tape's length, width, mass, surface area, and its weight, calculated using gravitational force. By using the equation for the E field of a uniformly charged rod, we are able to estimate the charge of the tape. We equated the magnitude of the electric force equation to the magnitude of the gravitational force equation, in which we rearranged the equations to determine a value for Q, our charge, which turned out to be 2.05 times 10 to the negative 8 coulombs, when plugging in our known experimental calculations. Here are the constant components used in the glow script code. Here is the electric field equation along with the tape components of the glow script code. The electric field equation came from the equation used in our Lab 1 procedure. Here is the electric force equation along with some remaining components of the glow script code. And finally, here is the glow script model's display along with the completed calculations. The charges of the tape were 2.05 times 10 to the negative 8 coulombs. Artificial electrons were 1.3 times 10 to the 11th electrons, which was determined by dividing the charge of the tape by the value of an electron 1.6 times 10 to the negative 19. In order for the suspended U-tape to float, the net force must be equivalent to 0. Therefore, our gravitational force is equivalent in magnitude to our electric force. Some possible sources of error include error in the calculations due to rounding, and possible inaccuracies of tape length and tape width measurements, along with measurement of separation distance. Comparing the estimated value of the charge obtained when using our experimental data to produce a point charge model compared to our line charge model, we can see that the line charge model displayed a greater charge than the point charge model. Some differences include the charge being uniformly distributed rather than reduced to a point, and the line charge model considering the length of the rod along with the rod's distance from the observation point. Overall, the line charge is closer to the real value since it models the charge separation more realistically than a point charge. Thank you.